Hello and welcome everyone. In this lesson, we are going to look up to digital image sensor. There are many types of image sensors available in the market. As of now, we'll be understanding the CMOS sensor only. CMOS sensors are everywhere. It is the most advanced image sensor of now. Now let's understand what an image sensor is. In a simplified way, we can imagine image sensors as the human eye. It helps the camera to see the reflection of light. Once the image sensor catches the light rays on the surface and converts them into digital signals, the processor records those converted digital signals as an image. But to do so, you need to press the shutter button. So now you have understood what image sensor is. Now let's move on to the next part where we are going to discuss about different types of image sensors. As per size, there are different types of image sensors available in the market. Some big sensors are being used in the full frame or mirrorless cameras, whereas smaller cameras and mobile phones consist of smaller sensors. So why don't we use the same sensor in each cameras? Because these sensors are really expensive. Even it could be the most expensive part of the camera. Thereby, we can't use the standard size image sensor or the 35mm format in everywhere. Otherwise, the market has a significant demand for the budget cameras also. That is why, to reduce the overall cost of a camera, different brands cropped the actual image sensor at different sizes. Now you have to choose the most suitable one as per your budget and requirement. But hey, don't be upset if you can't afford a full frame camera right now. Crop sensor cameras are also good, or I would say they are excellent for some photography genres, especially where we require significant amount of zooming. But to understand the fact where we can actually compromise the full frame sensor, you need to know the fundamental differences of these uniquely sized sensors. Let's understand those differences with some real examples. Suppose you have three different cameras of three different sensor sizes and you are viewing the scene through the viewfinder to capture the landscape, then this is what exactly you see through the viewfinder of cameras of different sensors. Through the full frame camera sensor, you can see the most of the horizon, whereas the camera with a smaller sensor will only show you a crop horizon. The formula is quite simple. The bigger the sensor is, the larger field of view you get. One more thing that you should know about sensors, that the largest image sensor, which is a 35mm image sensor, is not the largest one, because there are no size restrictions for the image sensors. You can make an image sensor as big as you want. However, we use the 35mm format as the standard. The 35mm sensor or the full frame camera sensor has similar dimensions that we use to make a film of analog cameras. Actually, the concept of full frame camera sensors came from the 35mm films. We are using the dimension of 35mm films as the standard for a full frame camera sensor. So the rest of smaller camera sensors are cropped versions of full frame camera sensors at different sizes. So what are the apparent differences that we notice between full frames and crop sensors? The primary differences are field of view, low light performance, image clarity or ISO performance, and depth of field. We have already discussed the idea of field of view. So let's understand what low light performance is and how it enhances the importance of full frame cameras. As we know, the larger image sensor provides a larger field of view. Similarly, the larger sensor also provides better low light performance. As I already said, I will not get too technical, so let's understand this concept with simple examples. Let's imagine the image sensor as a water container. So if I give you two different containers of different sizes, the bigger one would contain more water than the smaller one. The sensor of the camera also works as a container of light. Dimension wise, the full frame has greater space to contain light reflections. So it provides better results when we have a limited light source around us. Now we will understand the idea of image clarity. Well, we all know that light makes photographs. Better the light condition, higher the image clarity you get. Therefore, when we have to take photographs in low light conditions, a larger image sensor could provide us with much better results than a smaller one. The reason is simple. The larger image sensor have more space to collect light than smaller sensors. The ISO performance of sensors will be discussed in the next session. Lastly, we have to understand the depth of field. It is one of the most important aspects of photography to be understood. The depth of field of a photograph has an immense power to attract viewers because it can provide the viewer an illusion of separation. See how the subject appears more prominent and separated from the background. We can achieve greater depth of field with two different means only, zooming and aperture. The concept of zooming is not required here, so we will only understand how the lens aperture is related to sensor size. In a simple way, with bigger sensors we get proper aperture. The smaller sensors decrease the actual aperture of lenses because of their crop factor. For example, when we use a 50mm f1.8 lens with a full frame camera to photograph a portrait at its highest aperture value, which is 1.8, the sensor also utilizes the highest aperture value of the lens. However, the same lens with a cropped camera decreases the aperture value. It means when you are capturing a portrait using a lens of 1.8 at 1.8 aperture, it gives you a result of 2.8 equivalent. The calculation is simple. So for portrait, commercial and other photography niche where the DOF is the priority, the full frame sensor is a necessity.